Awesome. So, hi everyone. My name is Eva. I'm from Customer Success here at KNIME, and I'm super excited to see that many people here on site, also so many people online. And yeah, it's my task to walk you through that evening. And so, first of all, of course, warm welcome to that Data Connect. So that is one of our first hybrid events, so on-site and online. You see that cool map over there is our gather town, right? And to put it a little bit into perspective, actually, Data Connect really are our events driven for and by the community. So we need all of you to engage. We need you to provide us with topics that are of interest for you and so on. So yeah, as you can see on that map, we have Data Connect all around the world. And spoiler alert, the next one is coming up in November in Munich, actually in German language. So happy to see many of you there as well. Yeah, and another promotional slide. I think many of you have heard of it already, KNIME Fall Summit, coming up mid of November. And we're super happy to see you there as well, either on site or online. We have speakers from various companies such as Siemens, and we have Harvard over there. We have workshops, webinars, whatever you want to think of, you name it, we got it probably. And yeah, so feel free to register as well and attend. And enough of that, let's go through the agenda. So you all found your place. You're nicely seated. Probably some of you have already, yeah, you seem to all have drinks. Hope it's the same for our Gather Town attendees. And I'm here for the welcome part. After me, we have my dear colleague walking us or bringing us onto a trip to the KNIME Python world. And afterwards, we have Markus, one of our power users from Deutsche Telekom, talking about his insights and sharing his thoughts on advanced visualizations with Python and KNIME. You see, it's a Python KNIME night tonight. And afterwards, we have the networking, aka pizza part. So stay for that as well. And there we also ask you for your ideas around the next topics, for the next Data Connect, and so on. And I think that's about it. Only one more slide, and then we're ready to go. So both presentations will be concluded with a Q&A part, and therefore we have Paolo. He's sitting over there. So he will screen the Gather Town chat and also walk around here to take on your questions. So happy to hear what you have to say. And for all the online attendees, hi everyone, you can also ask your questions in the chat, and please mute your microphone. If not, we're going to hear you, most likely, right? And yeah, if you have some troubles, we have more KNIMers attending online as well. Just text us and we'll be happy to help you. And enough about that. Anything else? I think we're good to go. So Monty, feel free. The stage is yours and have fun. There you go. You got this. Yep. Okay. Perfect.
Thank you so much, Eva. I think you guys can hear me, right? Awesome. Okay. Okay, so as mentioned in the introduction, I'm going to talk about KNIME Python, and that's why the topic, the name I chose is Trip to KNIME Python World. And I guarantee that this will be a fun trip, at least for me, and hope it's for you as well. So about myself, I am Mahantesh, and I also go with the nickname Monty. I work here as data scientist, and if you have any questions regarding KNIME Python or in general any queries, you can write to me on this email ID. The topic that I'm going to cover today is about KNIME Python, but mostly explaining what is low-code approach. Then we have a simple use case. So instead of talking about KNIME Python, I thought of providing some demos so you understand how to build simple solutions, but that's for demo. You can build many complex things. Then the ways of building these solutions is either using the bundled environment or conda propagation nodes. I know this sounds like big terms, but by the end of this presentation, you'll be familiar with these two keywords. In every organization or group of users, you find this kind of groups. One is the no-code group. That means users who prefer visual programming and they like building workflows to do their day-to-day tasks. On the other hand, we have the red bubble. That means pure coders who like to use coding languages like Java, Python, etc. to perform the tasks. But what we are going to talk today about is the intersection, which is low code. That means users who prefer combination of both these approaches. And what they do with this is that they build complex solutions using drag and drop interface. And at KNIME as well, we provide various different Python nodes where you can insert your Python scripts and execute these nodes in workflows. We are going to discuss these nodes or these approaches in detail in the further slides. But as of now, the question arises that where can we use low-code approaches? A very typical scenario could be that there is this Python team, and then there are two non-coding teams, I would say, who are using no-code tools like KNIME, the marketing team and the finance team. And now if there is a Python package, which is typically focused towards finance matrices, and the finance team. Okay.
That one is not working properly. Yeah, perfect.
Okay. Thank you so much.
Sorry.
Yeah, I think, is this working? Fine. Awesome. Okay, so going again, I'll start with this slide again. So where can we use low-code approaches? As you see in the picture, there is a Python team, and then there are two teams here, the marketing and finance team, that are not well equipped with coding. So they use the no-code tool KNIME. Now, if there is a certain domain-specific package in Python that is suitable for a finance team, and they need this package for day-to-day use, right now they are not well equipped with coding, so that could be the blocker. But using low-code solutions, the Python team can use the KNIME Python integration and provide low-code solutions like workflows or components, which will be available to the finance team in the KNIME Analytics platform. They can just drag and drop these workflows or components and start evaluating or computing these finance matrices. This is just an example to show where low-code approaches could be used. Now, the use case that I wanted to discuss today, first of all, it's a hypothetical use case, and I decided to keep it simple and relatable so that everyone gets to know what the problem statement is. So there's a pizza company in San Francisco, and as usual, they have delivery agents who are responsible for delivering pizzas in the entire city. As you see, a delivery agent could typically start from one location, and he or she might keep delivering pizzas on a particular route and end the trip after reaching a particular location. Now, the company wants to calculate the total distance traveled by the delivery agents using the GPS coordinates. I mean, this is as simple as it is, a simple relatable problem statement. Now, if we have to give a look at the data, there are two tables that are available to us. First is the trip details. That means the agent code, where the agent started the trip from and where the agent ended the trip. In this case, it's Golden Gate Park, and it ended at the Rincon Park in San Francisco. The second table is location coordinates, where we have the GPS coordinates for all the locations in San Francisco. Now, as a data scientist, when I look at these two tables, I can see that if I join the data on the trip and the location column, I can get the entire trip coordinates for this particular agent. Now, the task here is to calculate the total distance between Golden Gate Park and Rincon Park along this route. That's how the problem statement is. Now, typically, when I researched how this can be computed, I found out there's a geometrical formula called as the Haversine formula, which is used by various apps, I would say, to calculate or to estimate the distance between 2 points. Now, I'm not going to discuss about the geometrical formula or how it was derived, but what I wanted to point out here is that it is mostly used by many, I would say, apps to estimate the total distance. Now, if you look at the formula, it includes a lot of sine and cosine because of the geometrical formulas. But if I am trying to build a solution using the Python code, what I can do typically is write a Haversine function, a function that would take in the input, the start and the end coordinates, and calculate the distance using the complex formula that I showed for Haversine, and return the distance to us. Now, using this Python formula, if I run the code use on the table that we have supplied, I can see at the last we have an output column which is called the trip distance in kilometers. And now this is a cumulative distance. If you look in the beginning is 0, and as the delivery agent goes to the next locations and it finishes at the last, it shows you 15.93 kilometers, right? It's how you do it in Python. You write a function and then you use it for distance computation. Now, if I were to do it using a no-code approach, as you see in KNIME, what I do is I just take the two tables, I join it, and then in the first annotation block, you see this is about reading data and manipulating it. And in the second one, I'm computing the distance using the same formula, but here I'm writing, I have a meta node that does all the cosine sine formula using the math formula nodes. But now, in this case, the advantage of using a no-code approach here could be that it's easy to develop and maintain. As you see, it's easy to explain to others that this is the block where the data is read, and then here the distance is computed. Now, if tomorrow we see that there is some change in the source of the data, you can simply change the source of the data here, and still the workflow can be executed pretty easily. And also, if you are supposed to share this workflow to your colleagues or to someone, it's easy for them to interpret and make changes thereon because of the simplicity of this no-code approach. Now, as the point of discussion is low code, as you can see, I said low code is basically a combination of both. So the workflow remains the same. What we have is the Python code that we already have for Haversine. We just copy the Haversine code and then insert it into the Python script labs node. So as you see, what I discussed about the low-code approach in the beginning is that you have a drag and drop interface, and then there are these Python codes. There are existing Python codes which you can directly use inside the KNIME platform. But before going ahead, I'd like to discuss about the Python script labs node. So the Python script labs node is currently part of the KNIME Python integration labs. That's the KNIME extension. What it offers is that it offers improved performance over the non-Python Python script labs node that we had earlier, and that we still have, but the labs version is much more performant. And now you can access the data as both pandas data frame and pyrs table. And the last point is that even the large data sets can be handled by this node because it uses the concept of batches, where the execution can take place into batches and it does not overload your RAM. If you want to know more about these technicalities or details, then there's this blog post where you can understand how to access data in different formats like .2pyrs, .2pandas, and the API information. But at this point of time, I like to go to KNIME Analytics platform and show you how the Python script lab node looks and what are the script where you can write your scripts. Okay. In the KNIME Analytics platform, as I said, if you want to have the Python script labs node, you should install the Python integration labs extension. And we can do that by file and then going to install KNIME extensions and just writing Python labs. Okay, so this is the extension. I can just select it and keep on clicking next, and then this extension will be installed to my system. But as of now, I already have this extension, so I am going to skip this step of installing. But what this will typically do is that if you go to node repository and if you write Python labs, Python script labs. Yep. So you can see that the Python script labs node is now available in the Python labs. So this node was made available here because I installed the extension. Now going to the first workflow, which I already showed you in the slides, that we are joining the data and then we're doing some kind of manipulation to get the longitude and latitude information. Uh, I can show you the data here, how it looks like. This is the same thing. We have the agent code, the trip information, and longitude, latitude information. Now, if I enter the Python script labs node, you can see there are just different sections to this. The first one is the script panel, then there are executable selection panel, and they run. At the input, you can see all the columns that the input table has: agent code, trip point, longitude, latitude. And here, as you see, I had just pasted the hover sign formula that we had in the Python code that we had. And in, at the end, when I'm going to calculate the distance, I'm just going to say hover sign, start coordinate, and end coordinate. And now, by providing this information or just copying simply the Python code inside this Python script labs node, if I execute it, it will take a couple of seconds, and then you can see the table, which is providing you the exact information that the Python code provided. The total distance traveled is 5.935 kilometers. But now my question to you is that there is no Python installed on my system. There's no Anaconda or any other distribution. But still, I was able to execute this Python code. How is this possible? I mean, anyone can answer. Even the chat you can answer. I can repeat the question. So I copied a Python code and I pasted it inside the Python script labs and I executed it. The Python code was executed successfully, but I do not have Python installed on my system anywhere, or neither any Anaconda distribution which supports Python. So how was this node able to execute Python code? Okay, so the answer is bundled environment. And to explain that, I would go back to slides. Okay, so as you see, when I installed the Python Labs extension, so with it comes the inbuilt Python environment, which is called as bundled environment. So what we wanted to do is that once a particular user installs this extension, he or she can directly start coding in Python, because we provide you a selection of Python packages, which is a list here. Now, if you see, if you want to do web scraping, then you have the beautiful soup already installed. If you want to do machine learning, then we have scikit-learn, pandas, numpy. And also if you want to do visualizations, we have seaborn and so on. So that's how the Analytics platform was able to execute the Python code, because when you install this extension, it installs a Python environment inside your system. That's it. Now, if you want to read more about it, then we have the bundled environment documentation, which will help you to read about the environment and this list of packages. Now, moving on to next point. As you see, with every task, you always need to do some updates, or there is something better that's available in the market. Same thing happened here. When I was going through the Python packages, I discovered that there is this package called as GeoPy, which is able to compute this distance much accurately. Initially, I wrote the big formula with some kind of Earth radius, etc., right? It was just me writing the function in Python. But now there is this package which computes the distance accurately and also provides it in kilometers and miles. So this motivated me to use this package for the distance computation. If you want to read more about this package, then the documentation is linked. But as I discussed in the earlier slide, that the bundled environment has only these packages. It do not have GeoPy here. And I want to use GeoPy package for my computation. So how can we do that? So it's fairly simple how to do this in KNIME. So we are going to look at this solution in a stepwise manner. So here the prerequisite is that I assume that you have already installed the Python integration extension, that Python Labs integration extension, and also you have Anaconda or Miniconda installed on your system. If you see in the beginning, what I do is now I switch from my bundled environment to the Conda environment. And now this Conda is going to use the Conda installation on your system, because we are going to use packages that are outside the bundled environment. That's why. the next step here is that once I create a Conda environment, it is it is a standard step, I would say, to create a new environment for a new project, so that the environments are separate, and then you can use them for your next updates as well. So after clicking on Conda, I go and click on new environment. What it does is it gives me this pane where I can write the name of the environment. In this, I'll try to name the environment as py39 geodistance because I'm calculating the geographical distance. I chose Python 3.9, and now this is the UI provided by KNIME. If you just click create new environment, it creates a new environment with the packages that are essential for the KNIME Python integration to work. And then if you open the Anaconda prompt and you activate the environment and just write pip install geopy, that is installing the library, the package that I want from Python. That's step 2. In step 3, as you see, everything remains the same. The Python script lab nodes even remains there from the initial low code ones. The only step that I do here is that the initial code that I had, the Haversine, the define Haversine formula code, I erase that, and instead, as you see here, I import the GeoPy library, GeoPy package, and I import the distance function from it because, as I said, it's much more accurate than what I was using. And at last, when I calculate the distance, I just say distance for the start and the end coordinates. Now, using this, when I replace this code with this one and execute it, it gives me the exact distance using GeoPy library. Now, the step 4 is pretty important and critical, and it will make sure that your workflows are executed on any system that you send. So what is step 4? So what we do here is we add a Conda environment propagation node. And why do we do that? Because just now we created a new environment and it has the Python package GeoPy, which we are using. So now when we use a Conda environment propagation and we connect the flow variable with the Python script labs node. So if you share your workflow with other users or to KNIME server or to KNIME hub, then it would ship this environment which you just created along with this workflow, so that when somebody executes this workflow, it checks whether this environment is existing on the system. If not, then it executes the system, so that you won't get errors saying that this package not found, that package not found, because you are shipping the entire environment with this workflow. That's how amazing this Conda environment propagation node is. So how to configure it? Simply, first of all, you drag the Conda environment propagation node. After dragging it, if you double click on it, you'll be able to see this kind of panel, configuration panel. And I have decided to use the Conda environment, which is geodistance, which we just created. And then I click on this option, which is include only explicitly installed. That means the packages that are installed afterwards, which is like the GeoPy package and the packages that are not dependent on the OS operating system. That's why I click on this option. And the flow variable that's coming out from here, I decide to name it as py39 geodistance so that I can use this flow variable afterwards. That's it in step 4. A simple thing is that now once the Conda propagation is configured, you just have to go to the Python script labs node, and in the executable selection column, you have to use the flow variable that you just created, which is the py39 geodistance. That's it. In these 4 steps, now your workflow is ready. You can share it on KNIME Hub, KNIME Server, or to any of your colleagues, and they can execute this workflow without any compilation errors because you are shipping the environment itself with the workflow. Now going towards the demo of this. Okay, so as you see, the workflow almost looks similar, just this part here is new, the Conda environment propagation. So I can double click and show you how the configuration looks like. It will take a moment to load the packages that are inside this environment. Collecting packages. And as you see, I have named it the output variable, and the Conda environment is the one that we created. And you see that I am shipping the GeoPy package with this. In here, you see the blue tick to GeoPy. So that's how you build low code solutions with packages that are not available in the bundled environment. But as we know at KNIME, if you want to make your work reusable and reliable, we prefer to build a component out of it, because then these components could be shared easily and anyone can make changes, supply their own data, and find out the distances. So to do that, what I can simply do is select these nodes and create a component out of it. I can name this component as geodistances, and then because we are using GeoPy, I can just say GeoPy. That's it. So this will create a component out of this, and now this component can be shared on KNIME Hub to other users who can simply supply their own data, their own location coordinates, and they can find out the total trip distance covered by a particular agent. It's taking a little bit of time. Maybe it's because of the online presentation. But what I did is I had already made this component and uploaded it on KNIME Hub, which I can show. Okay, it's created. Now, if I go to a new workflow where I see that I have information from a different agent, like agent number 008, and a different route taken by him or her. And now, if I want to calculate the distance for this particular agent, then I can just go to KNIME Hub and I can write the name geodistance using GeoPy, the component that I created. I can drag it from here, place it in the KNIME Analytics platform, and connect it. And after connecting, as the point of making the component was it's reliable and reusable. So I can just double click on the configuration and select the trip column, which is trip point, the latitude column, and then the longitude column here. And if I press OK and execute, this component will be able to compute the distance traveled by the agent 008. Execute. Okay, it will take a couple of moments to execute based on the data that we provided. Until that time, I'll just wait another second to check. Yep, it's done. So, okay, as you see, agent 008 has traveled like 7.6 kilometers. And if you want it in miles, then it's also 4.7. So that's how easy it is to build components using Python, KNIME, and share it on KNIME Hub, and anyone can use it to compute the distances. Going back to the slides. Okay, all right now, whatever we discussed, it was about the no code and low code. But what about pure code, like the pure people who prefer pure coding? So with KNIME 4.6, we have this feature where you can develop KNIME nodes using Python. That means now Python developers can write all these different codes, and then these codes will be converted into a KNIME node which could be used by anyone. As you see in this picture, we wrote the Python code and then we made a node out of it which is called the geodistances, which is exactly what I showed. But now it's a KNIME node rather than having a component or a workflow. It's a KNIME node which could be shared to anyone, and which could be shared to anyone in your user group or in your organization, and they don't even have to bother about Python installation on their system or not. They can use it just like any other KNIME node. If you want to know how to build this type of nodes, then recently we wrote a blog post, 4 steps for Python team to develop KNIME nodes. You can visit this blog and read about it, because we mentioned it in a detailed way. How do you do that in a stepwise way? And now typically the same scenario which I started with, here now the Python team can just build everything in their Python script and make a node and supply it to the finance and the marketing team for their users. Now, before I go, all the workflows that I showed are already available on this public space. You can go to this public space and download these workflows, and they'll be executed on your system, because I said we are also putting in the Conda environment propagation node here. Before I go to the Q&A, I would just like to show a little bit of visualization that I tried to build. On top of it, I saw that the Python library was also providing me some kind of visualization. So instead of just looking at the total distance traveled by the particular agent, I was able to also visualize the route on the San Francisco map. So as you can see, the particular person started from the Golden Gate Park and took this route and then reached the Rincon Park. So this is actually the San Francisco map, guys. So many things are possible with this integration. And I think up next is Markus, who's going to talk about advanced visualizations with KNIME and Python. So this was just my try to show how it can be visualized. So I'm open to questions right now if you have any.
We need to share the microphone, Monty, because this really nice microphone. So thank you. I will enter in the chat, and I must say Markus was, having a nice fun answering your own questions. But for example, I have also a question for you. So you're saying that if I have really popular packages like Panda, scikit-learn, and I want to run this script with some basic packages, I just need to install KNIME, install this new extension and start coding. No, nothing else, correct?
That's it, yep. Just install KNIME and then this particular extension. You can start coding in Python in there. It doesn't require you to do any configuration of Python, nothing. That's right. How amazing it is.
Okay, cool, amazing. So before I take questions from the crowd, just a moment, guys. I know you're full of questions here. But I have a question here from the chat that is asking, Ulrich, I don't know his last name, is asking, or she's asking, can you hand over your workflow, including the Python code, to another user to execute? Would you answer that? Yeah.
Yeah, so that's what I did. Whatever I showed, I am providing it I provided the link at the end, and you can do it the same way. Just make your workflows using the conda propagation nodes if you're using packages outside a bundle and share it on the hub. It's as easy as it is.
All right. Yeah, I think also you shared your workflows, right? And I think the camera is that way. Hang on, let me move. All right. So yeah, I mean it's really focused. Anyway, the point is that it's gonna work. So are there any questions from the audience? Anyone? All right. Oh, here.
I have a question regarding to the Anaconda environment. You said to produce an environment and include it in the delivery, you have to have installed Anaconda on your system, right?
Yes.
Yeah, but when you propagate it, then you don't have to have it on site. Or does a user of this node, of this new created node, have to have Anaconda on site as well on a local basis?
Yeah, that's right.
Wait, and second, because we have people online who want to hear you. All right.
Yeah, that's right. So if you're using the conda environment propagation node to propagate the environment from your system, then the user must also have the conda installed on the system so that they could recreate this environment that you just shipped.
If I might add to that, in the case that this is really a problem, right, that Anaconda installed next to KNIME for user, it is a problem, the new full code, pure code feature is going to help, right? Because in that case, when you install the extension that you create as a developer, they are going to automatically install Anaconda like that. So it basically depends to what extent you want to develop your node, whether it's a workflow, a component, or whether you want to actually go full in and make a native Python node. So I hope this also, yeah.
I just was compared by the scenario you created with finance and the marketing department, who usually don't have Anaconda environments, right? Maybe they have KNIME, obviously they have, because then they can use it, or use it just in browser and server-based. And then it was a question, even if I develop a unique, dedicated KNIME node, as you mentioned in the last part, how's the situation then? Is it you have to have Anaconda installed as well, or is it just a native node then?
Yep. So if you are if you're building a Python, if you're building a KNIME node using the Python code, then the user should not have the dependency of installing Anaconda and Python. They can use it just like any KNIME node. That's it.
Any more questions? If not, you can always find Monty afterwards for the networking session, and also developers here. There is Benny here from the Python team. But I would say that it's time now to welcome Markus on the stage, the virtual stage. So maybe you can move your character, Monty, and let him in. You see him. It's M. Lauber 71. Cassiana is right in our way. Maybe try the other side of the stage. Yeah. All right, almost there. Okay. And here it is, Markus. Okay, Markus, speak up. Here, we can hear you. Amazing. All right, yeah, click there so we can see him. All right, here is Markus. All good, Markus?
Yes, everything's fine. I hope you're also fine. And
Yeah,
great presentation. Thank you, Monty. Great introduction into KNIME and Python. And maybe I can add to this. Let's see if I can share a screen. I'm not sure if you want to make an introductory speech, but I can take it from here if you want.
All right. Yeah, take it from here. Yeah. Thank you.
Yes, I would like to talk about advanced visualizations with Python and KNIME. And I would like to start with my sort of inspiration. The inspiration to do some graphics with Python came a few years back when a friend of mine wrote a book about statistics between Germany and Austria and some interesting stories. And he wanted to include some graphics, and he asked me to, well, do the graphics. And I have to admit, I'm not a big expert in graphics, but I say, how hard can it be? I'll just give it a try and do it through Python. As maybe a lot of you know, with Python, you can do quite nice graphics. You can sort of hand code them. You can every element and stuff like that. So quite nice graphics can result from that. And so I thought, okay, interesting. Maybe we can also sort of convert this in the direction of KNIME and use Python to do KNIME graphics. Maybe as a little in between, KNIME actually has a lot of graphic integrations already, maybe too much, but that's up for debate. I have listed them here. We will not go through them, but just so in case you have them. And also there are these new visualization nodes that pretty much go in the direction of what I'm about to present to you today. So there are a lot of graphics integrations, but you can also do some with KNIME and Python together. You can just do it like that. You use a Python view node, you hand code the thing like I did for the little book, and then out comes a graphic, and you have this graphic. Okay, that's fine. You can use that. I have done this before, but maybe we can take it up a notch, like Monty has already shown. You can do it within a component, so you get even more comfort out of it. And I want to show you in a small live demonstration how this is done. And then we go into details how you come about such a presentation. And in this case, we have this little graphic. It's called boxen plots. It's a variant of box plots used to present quite large amounts of data and to be able to get a grip onto this data. And to show you what's going on, I'll switch over to KNIME. I hope you can see KNIME. Yeah, you can see it. Let's see. Yes, you can. Okay, what we have here is data from diamonds. This is a typical data set used for seaborne libraries. So this is diamonds and several information about these diamonds, how much weight they have, how they are cut, their color, clarity. I have no idea what depth is with regards to diamonds, but nonetheless, and of course their price, which is also interesting. And this data is read in here, in this case for a Parquet file, but you could also use a CSV or stuff like that. What about this? We will come to this later. And now here is a little component that I've already prepared. And when the data is being sent to this component, we can now configure this component, and I show you what it does and how we create such a component. We'll come to that in a moment. As you can see here, I have included boxes for the title. I can choose that the clarity should be on the x-axis. I can insert a label. I can then insert the y-axis. I can put in a footnote. I can do something with the scale, and I can choose a basic color. And if I do that and then execute the whole thing, out comes a nice little graphic, I hope. Yes, it is. Here's the graphic. It has the labels in it, and has the color and stuff like that. And yeah, and then of course also I can save it later and have it as a PNG file or SVG support vector graphic file. Okay, so far so good. And now we want to have a look how we can do such a thing. The first thing I do is I select a nice graphic from maybe the Seaborn gallery or from the Matplotlib gallery, and say, oh, well, this graphic looks nice, for example, to present my diamonds or my other data. And typically accompanied to that is a little Python code. I can just copy. I mean, I could just sort of use this Python code, but then I would also always have to sort of hand code it and to reuse it. And what I then do is I just copy this code, and then I bring it into such a Python script labs node, and I check which parameters are sort of the variations that I might want to change when I reuse this sort of code for other x-axis and y-axis variables. And so I make it into a flexible flow variable. You can see this green and blue markers here. They come in as flow variables from KNIME, and then they get used here for the Seaborn plot, and later on the Seaborn graphic gets exported. You can later download all these examples and can try it out for yourself, so you can see how this works and that you can easily change these parameters and nearly use all kinds of interesting graphics to your advantage. You can also do things like this. As you might have noticed, with the diamonds and their specific sort of cut, there is no predefined order. I think if you would just throw the data at the node like that, it would just use an alphabetical order, or would just I don't know, use them as they come. But if you want to define a specific order, you can also do that. Of course, you can just do that by hand, but you can also let KNIME calculate an order. In this case, it's the average price per clarity. I just came up with that. And then you would automatically calculate the setting and also transfer that as a flow variable to the Python node in order to be reused later. Yeah, then you would turn the whole thing into a component like Monty has already shown, and then you have the little boxes where you can enter these flow variables, and they will be then transferred to the Python Labs node, and you have quite a great flexibility with that. In the beginning, sometimes these settings, they look a bit challenging, but I think once you get a grip on that, it becomes quite easy, and you can then later on reuse this components for other data, and you can just change the title and stuff like that, and be fine. Yes, you do it like this with this string input or other input nodes. You have the little dialog on the top of your KNIME window, and there you can do configurations and, for example, order these string inputs so that they then will show up at your component, and you can design the look and feel of your component dialog. At this stage, a little reminder: if you build components, always remember to let the flow variables in, because by default the flow variables will be locked out. And in this case, I wanted to include this rank order I calculated, or maybe the graphics title, and so I have to let them in specifically. Please remember that. Yeah, this you can also sort of transfer the other flow variables into the node. Like, for example, I created a title outside this node. Of course, I could have done it just by typing it in, but in this case, I wanted to have a flow variable from outside. And so the title now is being inserted through another flow variable. So you are very, very flexible in combining all these things together, and hopefully you get a nice graphic out of it later. Yeah, the final workflow then looks like this. We have just seen it, and you can also download it and try it. And I would like to mention that the Seaborn and Matplotlib, these Python packages, they are already included in the bundled version. So if you install this bundled Python version with KNIME, you do not need any extra Anaconda, Miniforge, or whatever environment. You can just use it like that, and you have these very powerful images and graphics at your fingertips with the help of KNIME. And yeah, just a small hint for the export thing. This sometimes can be a little bit confusing. If you export things from the image ports, these little green image ports, typically I would convert them to a table, and then I would use a support vector graphic renderer to transfer them into a portable network graphic. This is sometimes a little bit confusing, but this is the way to go to have a binary image file instead of a vector graphic in the end. Just a small reminder that this should be the way to go, and you can also adjust the size of the images. This is an extra hint for you to make things more comfortable. And then I would like to take it up a notch and not only use a component, but use an interactive component like a little web application. And for that, I would like to switch back to KNIME. And down here, we have nearly the same thing like we have seen before, but this time I can use it as an interactive view. And then this whole thing opens up and gives me a dialog where I can change a lot of things. I can change the x-axis. I can change the y-axis. I can change the descriptions. And down here, I have the graphic, and I can also download the graphic as a PNG file. I'll just have to press execute, and then hopefully it does a little calculation in the background. You see these little circles running, and hopefully the name would change. And here's the new graphic. And to prove to you that this is not a trick, but it's really doing it, I changed the basic color to green and execute it again. And now I have the whole thing in green. I can see it here in my interactive view. And I can also download the PNG file. And I've also given it an individual name so that I know I can differentiate it between in the last one. Maybe we call it green so that everybody's happy. Execute it again. And now it's called from KNIME green and with a timestamp, and it's actually green. And you can change the explanations and stuff like that. So this is also quite nice. I think we do not have time to go into the full details of how to set up such an interactive view. There are several links in the presentation you can download, and also in this example graphic, I will send the link to that in the chat in a moment. But we can just take a small look into this component, and in this case, it uses the several widgets that have been configured here, and it also uses the quite new refresh button. This is the little execute button that I have shown you, and so with these widgets, you can create a dialog. It looks a little bit confusing at first, but I think once you just tried it, you'll get a handle on it. And if you click up here, you can then create your component. You can create your dialog, and you can put an input widget here. You can put the refresh button here. You can put this file download widget here, and so on. Here you have the view that you saw before, and you make an interactive dialog. And this is how the image here is exported from our Python script, and a temporary folder is being created. The PNG file is written here, and then it's presented as a download widget and also as an interactive view, so that you can see it and download it at the same time. Yeah, and that's I think a quick look into what you can do with advanced graphics and KNIME and Python. And yeah, that's about it. Okay, this is the information. Yeah, there's much more on the KNIME Hub about KNIME and Python graphics. So if you just type in Python and graphics in the KNIME Hub, you will find a lot of examples there. And as a little outlook for further maybe talks or for further explorations, the same thing can be done for R graphics. So if you are into R, or you have a special code that uses ggplot2 or something like that, you can also do that. And I have also prepared a few graphics on the KNIME Hub with that. You can apply the same logic to R graphics, and yeah, and hopefully enjoy KNIME and R and Python together, and have the best of all worlds under the hood of KNIME. That's it from me. Thank you very much for listening, and I would like to take questions.
Hi, Markus. Can you hear me fine?
Yes, I can.
Okay, awesome. So I don't know if you heard people were clapping here.
Yeah,
okay, good. No, it's all this hybrid adventure here. Okay, so I had first of all a comment. So you showed us a really great data app towards the end, right? Like with all this refresh logic where you can put some input, get some output, and refresh. Like, to build that, did you require any software development background? Like, if you can comment a bit also about your background, right? Like, and what it took you to get this far with all your skills about building this data app and all the other things you showed us, right?
Yes, I can do that. I'm not really a developer. Or of course, I can code a few things, but this is also often just copy paste from Stack Overflow, but don't tell people. And the great thing is, with the tools from KNIME, it's quite easy to put such a thing together maybe in 1 or 2 hours. And if you then familiarize yourself with it, it will become even easier. So I'm not a developer myself, but I was able to put this together in quite a short time. And I think there's more you can do with that, even without being a full stack developer. I'm just a humble data scientist trying to do something with data. So KNIME really helps in that regard, and especially the bundled Python version. This is really great. All the things you have seen, no Anaconda, no Miniforge. It's just a bundled Python version from KNIME.
Cool. Thank you. That was super cool and inspiring, I hope. So before we take the questions from the audience, I have a few questions from the online audience, which is still
Yes,
an
of
audience.
course.
So we have Mark. This is, I think you said it towards the end, but again, he's asking, are these components that you show available in the hub?
Yes, they are all available. I just posted a link in the chat, but you can also just go to the hub and type in Python and graphic, and then I think they should come up. And there are also links in the presentation that you can get at the slides. So just go to the KNIME hub and just type in Python and graphics, and I think they will come up. And typically, with my example workflows, it's always good to go to the additional links, because typically there I have additional links to other articles or graphics or stuff like that. So also check out the additional links.
Okay, awesome. There is also another question from Stefan. He's asking, out of curiosity, he says, can you change the aspect ratio of the plots on the Python side?
Yes, you can. This is sometimes a little bit tricky. You will see that I think I have an aspect ratio of 16:9 somewhere in there in the code. You can change that. For the book, it took me a little bit experimentation to do it, but yes, you can do that. Just find an interesting example and toy around with it, and you can change the aspect ratio. What comes out from the Python Labs node is a support vector graphic, so you can also change their aspect ratio. But of course, you have to be careful. If you do it in a very extreme way, maybe it doesn't look that good. So just try a little thing back and forth, and I think you'll be fine.
Okay, awesome. I think there is just one last question from Ashok, but he's asking about the KNIME Power BI integration, and which is the best visualization platform for KNIME with the most features. I think you show a slide with like 10 links or something, right? Do you have any preference personally on the platform, or Power BI in particular, he's asking?
We are using Power BI, but not me at Deutsche Telekom. We typically would use MicroStrategy. So I cannot speak to Power BI. I think it very much depends on what you are using. I think if you just use KNIME and KNIME Server, KNIME is also moving towards, let's say, more interactive graphics. It's the highlighted link on my link page. So I think I cannot speak to Power BI, unfortunately.
All right, awesome. So are there any questions from the audience now? Anyone? Any question? Monty down there, have any question? No, you're good? Okay. All right. In that case, maybe I can give the mic back to F. I mean, you can still find Markus on the Gathertown map, and maybe we're gonna, I'll just give the word to
Stay with me, of course.
Oh, I can stay here. Okay.
So yeah, thanks Markus, and thanks Monty. He's already close by the pizza. I feel like somehow the audience already came closer to the pizza. I don't know how that happened, but very good. So first of all, thanks to everyone. Thanks Markus, thanks Monty. Thanks for all the friendly little helpers who made this possible, the event. Thanks to the community. And now I think there's not much left to say. Other than all the people online, we invite you to come to the beach now, right? Yeah, where you will have the educators corner and the organizer board. And to all the people on site, now it's time for the networking part. So please feel free to grab another drink, have a piece of pizza, and then we also have the organizer board and educators corner around the corner, actually. So thanks everyone, and happy KNIMing, right?